This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today we'll practice finding the domain and range of various functions. Let's check it out. What are the domain and range of y equals the negative absolute value of x plus 1 plus 3? In other words, what are all the x values that we're allowed to plug into the equation, and what are all the y values that it could possibly produce as outputs? Is there any real number we can't take the absolute value of? No. So there are no restrictions on what is allowed inside of an absolute value function, and so the domain will be all real numbers from negative to positive infinity. Now let's find the range. We know that whatever comes out of the absolute value must be a positive number. It must be greater than or equal to 0. So to find the range of the entire function, let's substitute 0 in for the absolute value expression, and then simplify. The value of 3 for y represents one edge of our range, either the minimum or maximum value. Because the absolute value has a negative multiplier in front, we know that as its value increases, we will be subtracting bigger and bigger numbers from 3. So this function will only produce y values less than or equal to 3. In interval notation, we write this with a bracket next to the 3 to indicate 3 is included in the range. This also makes sense if we consider its graph. This equation represents an absolute value parent function that has been vertically reflected over the x-axis, shifted left 1, and up 3. Sure enough, the function looks like it extends infinitely left and right and only exists at or below y equals 3. So our domain is all real numbers, and the range is all y values from negative infinity to 3. Let's look at another function. This time we have a square root function. Y equals 5 times the square root of x minus 3 minus 4. When working with square roots, we know that whatever is underneath the radical must be greater than or equal to 0. This will help us find what x values we are and aren't allowed to plug into our function. The radicand of this function is x minus 3, so we know that x minus 3 must be greater than or equal to 0. To isolate x, we should add 3 to both sides. This means that as long as x is greater than or equal to 3, the radicand won't be negative. So our domain is all x values greater than or equal to 3. We also know that the value of the entire radical itself must be greater than or equal to 0. So to find one end of our range, we can find the value of y when the entire radical is 0. Simplifying the right-hand side, we see that when the radical equals 0, y equals negative 4. This could be the minimum or maximum value of our range, but because the radical has a positive coefficient, we know that the y values will only increase as the value of x increases. So our range is all y values greater than or equal to negative 4. Let's look at the function's graph to validate our answers. The square root parent function starts at the origin and extends infinitely upwards and rightwards. The negative 3 and negative 4 have shifted it 3 units to the right and 4 units down. The coefficient of 5 has vertically stretched the graph, but this actually doesn't have an impact on the domain or range. In the graph, we can see that the function starts at an x value of 3 and extends infinitely rightwards, and starts at a y value of negative 4 and extends infinitely upwards. Great job. Let's keep practicing. When considering what x values are valid inputs to the function y equals negative 2 to the x plus 7, you may notice that x is the exponent. There are no restrictions on values for exponents, and so our domain is all real numbers, from negative to positive infinity. Now let's consider what y values we could possibly get out. If the base of our power is positive, then it can only take on values greater than or equal to 0. Similar to our last example with the square root, we can find the y value when 2 to the x is equal to exactly 0. We find that y equals 7, which represents one end of our range. Because there is a negative multiplying 2 to the x power, as 2 to the x grows exponentially larger, the function will actually exponentially decrease as we subtract larger and larger numbers from 7. So the range is all y values from negative infinity up to, but not including, 7. In interval notation, we use a parenthesis with the 7 to indicate the 7 is not included in the range. Let's look at the graph to understand this a little deeper. 2 to the x power has a horizontal asymptote at y equals 0. The negative multiplier in the equation reflects the graph over the x-axis, and the plus 7 shifts the entire function and its asymptote upwards. So the picture matches our answers. The line extends infinitely left and right, so its domain is all real numbers. It also extends infinitely downwards, but has an upper bound of 7 that it will never actually reach. Nice work. Let's try one more example together. Our last function is a logarithmic function. Logarithms have the inverse restrictions on their domain and range compared to exponential functions because they are inverses of each other. So whatever is inside the logarithm must be greater than 0, and it is possible for the logarithm to output any real value. The argument of this logarithm is x plus 4, so x plus 4 must be strictly greater than 0. In other words, x must be greater than negative 4. So our domain is any x value strictly greater than negative 4. As for the range, the logarithm could produce any real number depending on the input, and so the range will be all real numbers. Seeing this graphically, the common log of x looks like this, and has a vertical asymptote at x equals 0, representing the limitation that its input must be greater than 0. This function has been shifted 4 units to the left, and so that asymptote has also shifted to be x equals negative 4. The x values can only be greater than negative 4, and the y values can be any number from negative to positive infinity. Great job today reasoning about the domain and range of these various functions. Keep practicing and strengthening your skills.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.